Hi guys. So 3.4 was an application of exponential functions for population. So this activity is another really common one for investing money. Okay, so this activity we're going to look at, it's all about investing money, but at different, it all really depends on how many times per year is your interest getting compounded. Okay, so we look at this first example where you're inherited $20,000, you get to keep half of it, okay, to invest, and you're trying to figure out what to do with the money, okay? And so the first thing is, suppose that you deposit in the bank and the bank gets 6.5%, which obviously now that would be unheard of. But what is the interest earned after 1 year? Okay, so if I take my initial $10,000 and I times it by 0.065, my interest rate, I would end up making $650 that first year. Okay, so obviously that's not, so that's the actual just interest earned, not the total amount that I'm going to have at the end. Okay, so now let's say we left it in the account for 10 years. Is it fair to just take that 650, that interest for 1 year, and times it by 10? Okay, so if I did that, what assumption am I making? So the assumption I'm making then, if I just times that by 10, is that I'm not going to be making interest on my interest. That each year I'm only making $650 in interest, and that was just on my initial investment of $10,000. So that's our assumption, that we only make interest on the initial investment, which really, that wouldn't be worth investing money, okay? Because if we only make it on the initial investment, we don't make as much as if we keep earning interest on interest. So meaning next year, for this one, we would make 6.5% of that $10,650, not just the $10,000. So simple interest is if we just made it on the initial investment, okay? But most interest, most investments, any loan that you take, things like that, you're paying interest on the whole thing, the interest on interest. Okay, so here's the example again. Okay, after 1 year, you have $10,650. So that after the second year, okay, you make that 6.5% on that 10,650, and you have a total amount then of this much. Okay, you're making your original amount and then interest on that second year. Okay, so if we look at this formula, they're giving us down here a formula for if interest income is compounded. Okay, sometimes you have interest compounded annually, semi-annually, monthly, quarterly. So this right here, this formula that they're giving us right here, is how we would figure out if it's not simple interest, if it's compounded interest. So P is that principal amount, okay, the first amount we deposit. The 1 in there is because our growth factor is 1 plus something. We have our growth rate and our growth factor. So R is our interest rate, and then this N right here that we see, the 2 spots in the formula, is how many times it gets compounded per year. So for example, if it's just once a year, N would be 1. If it's monthly, N would be 12. Okay, we're going to even look at if you get interest daily, it would be 365. And then T is always the number of years you're leaving it in the account. Okay, so that's compound interest. So let's look at one. Okay, so they're giving us, we're back to, oh no, this is a new example. You invest $100 at 4%, compounded quarterly. Okay, so quarterly is going to be, that N is going to be 4. We get 4 times a year. How much money do you have after 5 years? The one thing I do want to point out is that formula up there in the green box, that A is the total amount that I have, not just the interest, but the amount that I have after that amount of time. So we see here is our P. Okay, there's our 1. So we've got our 1. I'm just putting the formula underneath. So 0.04 is the rate. N is 4. N, T, that's where they're getting everything. N is 4 and T is for 5 years. Okay, so after 5 years, I would have $122.02. Okay, compounded quarterly. we're coming back to our original example. We're going to compare some different ways of compounding. It doesn't really make a difference. Okay, so back to our $10,000 that we're investing, 6.5%, okay, compounded annually. So let's figure out how much interest we would make then if we just put it in for, well, we're just going to look at the formula first, actually. So let's just rewrite the formula with that in there. So the amount we're going to have after that amount of time is our initial investment of $10,000. 1 plus 0.065 is our rate. This one we're getting it just one time. So you notice when we only get it one time a year, I could have just written 1.065. And then 1 times t. So that's really just t. So this is really more of our basic exponential function that we've been looking at. Okay, so let's figure out what we would actually have. If we did this out, really this is just 10,000 times 1.065 to the first, if this is only 1 year. Okay, so we knew that before because we really had done that on the original problem. Okay, so what's the amount of interest? Okay, same thing we found before. So now let's figure out, let's compare for part D. If I get it, well, this is the same, still compounded annually, just one time a year, but we're going to figure out how much we have after 2 years, 3 years, 4 years. So if we end up just keep doing this formula, so over here t is going to be 2, t is going to be 3, t is going to be 4. So after 2 years, if we take that formula, everything else is the same but t. If we do it for another year, we end up with $11,342.25. After 3 years, we end up with $12,079.50. And 4 years, $12,864.66. Okay, so the compound interest formula in part A defines A as an exponential function. What is the base? Okay, so in this case, if you look at our formula, the one I wrote, I'm going to circle it in red, this right here. Okay, what was our base? Our base was at 1.065. Okay, it was that way only really because n was 1 in this case. We only compounded it annually. Is it a growth or decay? Well, I'm making interest, so this is definitely a growth factor. Because we're earning interest. Okay, and it's greater than, the growth rate was greater than 1. Okay, so now let's say we do it, I'm just going to move this up a little bit more. Suppose we deposit that same amount, but now we're going to get it quarterly rather than annually, write a new formula. Okay, so now we're comparing. So now if we're going to do it quarterly, it's going to be our initial investment times 1 plus, okay, 0.065 is still our rate, but we get it 4 times a year. Okay, that's our formula, still not knowing how long we're going to have it for. So if I end up rewriting that, let me just simplify this part right here. If you do that out, okay, you're going to end up getting, it's going to be 10,000 times 1.01625 to the 4t. Okay, so then what would our balance be after the first year? Okay, so let's use that. Times 1.01625 times 4 times 1 to the 4 times 1 would be 10,666.02. Okay, so if you look at that one up compared to what we had up here, okay, let me show you where I'm at. I'm up here. Okay, after 1 year compounding annually, I had $10,650. After only 1 year, same amount of time, if we compound it quarterly, I have $10,666 about. So it does make a difference. I mean, in this case, it's only about $16, but it does change. So think about now, what if I did it even more times? So use the table feature in your calculator to determine the balance at the end of each for 10 years. So if you put this right here into, but with the t in, sorry, I really should mean this one up here. If I put this into Y1 and use my table, and I can kind of scroll down and see how much it's going to be. I can get the same table I made up above without having to do all the calculations and figure out what the balance is. Okay, so let's see, part C is what we were just talking about. Part D, write the function in the form A equals ABT. Okay, so that's like what we've been used to looking at, is in this form. Okay, so in this case, if we look at it, what would be this piece right here, even including the 4, whoops, I'm trying to include that 4 in it, that would all be B. So if I rewrote this formula, it would be 10,000 times, and then if I went over on my calculator and did this, that part, you're going to end up getting 1.0666. Okay, that's just rewriting in a different form. Okay, it's rewriting in the form that we're used to. So if you look at it in that form, now we can really see, okay, that one is yielding more. The one above, right here with the up here, with the 1.065, that yielded 6.5%. This one is yielding 6.66%. So what's the base? The base, when I rewrite it like in that form, is, so you can see that that one is going to yield more. Okay, now let's say we do it, now deposit our $10,000 with monthly compounding and then with daily compounding. Okay, so let me just, I'm going to separate this into 2 separate videos, but let's just go through. If I did it monthly, it means I would have 10,000 times 1 plus 0.065 over 12 to the 12t versus daily, it means I'm getting it every single day. And what I would encourage you to do before making that table on the next page is to take and rewrite each one of these like we did on the one just above. Calculate this part out right here. The 1 plus 0.065 divided by 12 to the 12. And then write that as your B. Find that and then rewrite it. And same thing for this one. It'll just be easier to keep plugging things in. Calculate that part as your B and rewrite the formula. So I'm going to stop this video right here, and I would like you to, on the next page is a table that you're comparing for how many years you invest in at different compounding periods. So fill in that table, and that's where our next video will start.